Hello dears, welcome you all for this Robotstructuralanalysissoftware class. Now today we are going to see the exercises for 2D trusses, how to analyze and design using this Robotstructuralanalysissoftware software. Let's be good to see, okay? As I'm opening the software, okay, you go to the new project, then 2D truss, we are going to do the same truss only, going to do the analyze, okay? Okay, so here the top ribbon and the side ribbon both we are going to use to make the geometry and loading and analyze and design part. Okay, first you go to do one by one. First tools, preference, just check the code. Okay, error code accepted. Then again go to the tools, then units and check anything else. If you want to modify, you can modify it. Otherwise, keep as it is. Okay, yeah, then I am coming to the grid 2 by 2. Yeah, I keep as it is and close it. Then the axis. Okay, the geometry, you check the geometry. The x-axis there are four interval, same interval 2.5. So I am keeping the repeating is there are four, the distance is 2.5. Add. Then I am coming to the z direction. Z there are two different height, sorry, there are two same height. There are two level. That's why the repeating is 1.5. So there are repeating is 2. The distance is 1.5. Then add it. After that, you can give apply. Our all coordinates are available. Then according to the figure, you can join each member. Choose the member. Here you have to first select symbol member. Then the section. Section you can any section according to the question. You can choose I section, channel, anything. Here I am choosing angle section. So CAA. Your case, whatever your case, if you want, you can choose it. Okay, and it is assigned. That's why it is asking, saying okay. Now the selected section is appearing here. Then you join according to the figure. I am joining the points. First member, second member, like that. I am first joining all horizontal members. Then I will join. Then I am joining the inclined members. Then put the vertical, draw the vertical line. Then join the inclined, this one, inclined axis. Yeah, I think all joints are connected. Okay, then you give the support. Go to the support. uh, Based on the figure, here it is hinged, here roller. Okay, first I am giving the hinged support, then I am giving the roller support. Then come to the load. First you give the load types. You can choose the live load. Add. Only one is enough. Okay, then close it. Then load definition, you can give the load because the point load. Then first we are going to give this 100. So it's acting downward, so minus 100. And you select the uh, record points. If you want to display the value, you can click the description. Again go to the loader, modify the value. Another load is how much? 50. So you modify here, minus 50. Add. Okay, then you can again you select the required points, then close. If you want to appear again, click the description, appear. Okay, so load is over. So after loading, generally what we should do, we should do the analyze. Yes, here you do the calculation. So the analysis is over. Then after analyzing, the result is ready. See the results. First see the reaction. Yeah, see the diagram. Total force is how much? 100, 100, 100, 50 plus 50. Total 400. That's why the reaction also is appearing 200 by 200, each support carrying 200 200. Okay, then if you want to find the member forces appearing here, maximum also, maximum minimum also, if you want me check, click the global extreme. Okay, then that stresses, then the displacement, all value appear here. Okay, if you want diagram also, you can take diagram, means you can take the diagram, go to the diagram, deformation diagram. I am just now, I'm just going to take, showing the example. Okay, then open the new window. Okay, keeping that viewpoint geometry, then apply, and here you can give the start. Here the displacement, the animation video is appearing. Yes, the displacement. Yes, once again I'm repeating the deformation diagram. So load and deformation you can choose, then extract, then you can click this start. It is running. After running, you can click open new window and apply. See the deformation that due to the load it is displaced like that. Okay. If you want animation video, you can click, if you first before clicking animation video, if you want you can screen capture it. Okay. If you want to see the animation video how it is deflecting, means you can click the run start, you can see the animation video. See, due to the load the deformation is appearing. Okay, this is your common average deformation. If you want vertical deformation, due to that how much vertically it is deforming. If you want vertical deformation, you can select this one, UV set, the exact deformation, because UV set is a pure vertical deformation. Okay, then open the window, apply. See the vertical deformation. If you want to see the animation, means again start. You see vertical deformation. Okay, so this is the analyze part. So analyze part is over. Okay, I will change this one. Search diagram. Okay, okay, dear. So here, actually, the trust about the trust we can do in the two parts. Part one is analyze. Part two is design. So the part one is over. Part one, all the results you can find from the results about the diagram, reactions, displacements, forces, member forces. Everything we can find from these results. Okay. Now we are moving to the second part, design. How to design means the joint, each joint how many number of boards we have to go, that's the main aim. We are going to do the design. Okay, here what we want to, what we can do means go to select the steel design. Okay, steel design, here you can click the connections. Okay, now the total window screen is changed. Okay, first here any joint we can do the design. Okay, first I am selecting this joint I am going to give the design. Selected this joint. So here the truss mean generally this about this truss load or this one we can choose. I am choosing this one because here there are three members. Yes, four member mean about this point mean you can go for this one or this. Okay, here only there are three members. That's why I am selecting the suitable sections here. So now clicking here. Yes, this point we require. Okay, this first you can simply close it. See here, after selecting, you can, now it is selected mode only. After selecting, you can click this one, new connection for selected member. Then only it will link. It will sync. After linking or syncing only, we can get the correct design output for the joint. Okay, now it is linked. Linked will all here appear. Okay, now after linking, here it appear geometry, code, pose, everything appear. Geometry means first here or bold or welded you want. Bolded means here. Welded means it is a welding point. It is all come. Now for us we record bolded. I have selected bolded. Then the chord bars, poses. If anything, any data, almost it is all default only. Based on that sections, it will go directly. Some distance, if you want, you can change it. There's some distances. If you want modify also anything, you can modify it. After you are modifying everything, you can click apply. Okay. Now after this, you can go for connection, then calculation. You can after calculation only your result will be ready. Okay, calculation. See now the result is ready. This is the diagram. This is your for that joint. This joint. This joint is selected as this joint. We have to give this gusset plate and gusset plate over. See here, each side we can give two boards. The two boards are enough. About a diameter, board diameter, anything if you want to check also, you can come here. If you here right click and properties, if you click me, it will appear here. About all details appear here. Okay, about the board related, every detail will is available here. Okay, so the result or the final results also is available in the bat format. This also we can save in our folder. Go to file and save as means it will be ready. Okay, yes. So this is the design work. The design work also we can do. Now we have completed for this joint. Like that we can do. Then this point also we can give the connection. The same procedure. Okay, each and every joint we can do the design to follow this same procedure. Okay, yes. Thank you, Shukran. Shukran.